Welcome, everyone. Thank you for attending the second annual MAP Connected webinar in our AI series. My name is Pam Walter. For those who do not know me, I'm the founder of MAP Connected Network for warranty, after sales, and aftercare executives, as well as we will all be all meeting in person very shortly, October 24th and 25th. In Dearborn at the Vehicle Service and Warranty Lifecycle Summit. I'd like to introduce our two moderators for today that have been selected based on their complementary experience and many years in the warranty and quality space. First up is Ted Danner, who has a background of 21 years working with Nissan and most recently for a leading service contract company. And secondly, Jason Payne, the owner of JPSI Strategy and Intelligence, who has worked for many leading tier 1 suppliers in the global warranty space and role, and performed 7 years as the chairman of the Warranty Council of OESA. I will hand it over to them. Thank you very much for joining us for the next hour.
Well, good afternoon. My name's Ted Danner, and thank you for joining us on the webinar, Demystifying AI, where the speakers will go into practical guidance and approaches for warranty management. Well, what do we think of when we hear the term artificial intelligence? Do we think of robots, self-driving cars, smart assistants, or even chess champions? Well, these are all examples of AI, but AI is the science and engineering of making machines that can perform tasks that normally require human intelligence. We'll share with you some of the amazing things AI can do for the OEM warranty business and as it is currently doing for our national security. Now, regarding today's speakers. Today's speakers include myself, Jason Payne, principal at Strategy and Intelligence Consulting, with Jason and I moderating the webinar, and Terry Bush, former Chief Data Officer for the U.S. Defense Intelligence Agency and the Department of Defense, and the Senior Solutions Engineer at Agolo, Daniel Schofield, who previously worked to build and implement software in the AI and robotics fields. And then regarding today's agenda, well, today's agenda, our deep dive starts with how the U.S. Department of Defense approaches AI, and then moves to AI for warranty management, then wraps up with what's next, and then Q&A. The speakers, here's the fun part. The speakers will show us what's possible and how this AI is reality now for the Department of Defense from a solutions provider outside of our industry. You'll come away with a few points, and I'll go over those quickly now. How AI overcomes the data ocean that warranty leaders are dealing with at our enterprise level. What read across analytics looks like. Claim classification delivering instant alerts through your existing infrastructure. Claim processing and decisioning, incorporating all your data sources. So let's buckle up for the perfect storm and trifecta of technology, of ontology, large language models, entity intelligence, and how that delivers on the profound promise of AI for OEM warranty. But first, we'll go to a couple items of housekeeping. And before we get rolling, please don't share, of course, some of these are real basic. Please don't share commercially sensitive or confidential information such as pricing, sales, supplier purchases, R&D, or similar. Also, feel free to type in your questions, but of course, be willing to answer from your perspective and your organization's perspective. The final piece on housekeeping, if you have a question, please enter it via the icon, the question icon. We'll cover it at the end of the presentation. A webinar recording will be posted to the MAP Connected website within 24 hours, and key takeaways and notes will be sent to the attendees within 2 to 3 business days. Regarding the survey, you may recall you filled that out or completed it a few weeks ago by checking the boxes on where AI technology can be most impactful for your organization. Well, it's no surprise that at the top is claims reporting, analysis, and fraud detection, coming in at 9 out of 10. And claims processing automation is next at more than 7 out of 10. Well, with these top two claims focus points leading the pack, well, it's interesting that the lowest ranked item on the list is synchronization and analysis of disparate data. Well, why is that? Well, this is the foundation which all AI rests. And to take us deeper in this is Jason Payne. If you could take it away, Jason, thanks a lot.
Thanks, Ted. Yeah, this last category really is interesting because like Ted mentioned, the synchronization and analysis of disparate data, it really is the backbone of many of the other categories that were in this survey. And this is especially true for tier one suppliers, since many of you have to manage incoming warranty and quality data in very different formats from as many as 20 to 80 or more automotive customers globally. And for many suppliers, the analysis of disparate warranty data is still one of the most significant pain points, since it, for the most part, is a highly manual process. But it's something that AI really is well suited to help address. So now, for me as a career warranty professional, I've always tried to look for new and innovative ways to address the problems that we all face. And AI really has one of the largest potentials in our space to really truly transform the way that we all work. Now, in terms of how and if AI can help, the next two speakers are going to go and touch on many of the concerns that you might have, as well as some of the priorities that your own organizations face, such as what recent AI innovations make real enterprise deployment achievable. Is this something that my company can actually do? How do I capture institutional knowledge and domain expertise amidst turnover? How do I make this technology work with my current systems and tools? How do I deploy a solution that can scale financially and predictably, whether in-house or via an external partner? And then what other industries are using AI to solve similar challenges to warranty, and how do they do it? And now this last point on the slide is one that I'm sure everyone on the call today is really interested in. Who is using AI now? Has it been successful in helping sectors that deal in large data sets to become more efficient and proactive? And is this something that my company can actually benefit from? So to help outline some of the real world applications of AI in environments that are similar to warranty, I'm going to turn it over to Terry Bush, who's going to give some insight into how AI has helped the US Department of Defense and parts of the intelligence community tackle problems similar to those that we face here in the automotive world. So Terry, I'll now turn it over to you.
Thanks so much. And thank you all for having me here today. This is a very different audience for me. Usually I sit at the pulpit and I'm talking to the US military. Today, and even when I'm talking to the military, I don't know some days if I'm preaching to the choir or the unwashed masses. So today we'll shoot in between here and hopefully provide some relevance to you. I have a background in U.S. government. I was fortunate enough to be a chief data officer and lead a lot of innovation and analysis for Department of Defense for 25 years. What I got to experience was the big data revolution and the cloud revolution. In our world, things changed. After Afghanistan and Iraq, our adversary became non-traditional and something that was hard for us to detect, and we didn't have proven methodologies to go out and find our adversaries. They didn't represent in large military bases and aircraft carrier groups. They were trying to get below the surface of detection. But they were operating in these big data platforms, which you know is social media, publicly available information, things like that. So we had to use good old ingenuity to say, hey, we learn lessons, right, already in big data. How do we transfer that? How do we learn and train against an adversary that is working differently than we've ever seen before? And the good news is what we had learned previously helped, and then we learned to identify a lot of other things. The real important message I carry today is that when we began to adopt AI technology, it worked. And at first I thought I thought we were a little bit lucky. Then I thought we were good. But at the end of the day, I think our approach was measured, pragmatic, and really, because we're the U.S. intelligence community, being wrong for us is very, very difficult. And I'll share a few use cases where I can today. I'll remind you, I have an NDA, like a lot of you have NDAs, but my NDA is a very serious NDA. If I violate it, I go to jail for a really long time. But I'll bring forward a couple of use cases that we learned in our training and our experiences here, and try to highlight, sort of best practices, where we got started, how it worked for us, some failures we had, some lessons learned we had. And if we go to the next slide, I'll get into those just a little bit for you. So the first thing is, it works, right? The field of AI can be, sort of broken down into a couple different types of AI, right? We are not talking about self-inventing software and AI that's writing its own language. What we're talking about is things like computer vision, machine learning, deep learning, large language models. These are the aspects of AI that now have maturity, have a ton of people working in them, have a good commercial, private sector, public sector, and open sector investment, right? You see, it's all investments of technology investing here, and we're getting good stuff, getting good stuff out, right? So the first aspect is we live in a day with scaleless computing called the cloud, right? Which can be expensive, and there's some pitfalls there. We have a crowd of people dedicated to making AI work and getting you practical results. The second part of this, and I'll come back to this because you can see in my title as Chief Data Officer, right? We never worry about too much data. It's enough data. AI works best when you can train and train and then train some more, right? And let that training continue ad infinitum until you're done. It's really, really important. And then build on those initial successes, right? What we did is we started with a very simple, and I'll get into it, use case, and then we expanded on that use case. We expanded on that use case, and the net effect at the end was, and often lost in the story of the great technology, is we gave our thousands and thousands of intelligence analysts time back. We're able to automate their processes just like you do and preserve their time. I have a saying that, our top-notch analysts are like highly trained surgeons. They have subject matter expertise that's beyond compare. And I want them like surgeons with their hands in the patient, not prepping the patient, not taking care of the patient. I want them in surgery. So my goal with AI was to keep them there, to do everything necessary, and where possible, automate many of the routines they were using. And when we did that, things began to snowball. We also, because we took a more pragmatic approach, we built trust between the human and the machine. That pragmatic approach is key to me. There is overinvestment and inflated expectations. There are lots of companies out there right now, I won't name any of them, who sell push button AI. They're going to give you a nice, pretty UX, and you're going to push some buttons. And they don't discuss some of the key aspects that I worry about. This is an iterative thing. This is a thing that takes time. This is a thing that you are constantly reinventing, right? There's never a stasis in what we're doing. Those easy button solutions are out there, and I know many of those companies. I'm friends with many of those companies, but caveat emptor, beware of over promises and over investment. And I'll talk a little bit about this in the other bullets here, but one of the things to think about, right, is hey, I don't want to turn my entire IT enterprise over to this. Not on day one. Anyone who asks you to do that, I worry about. Two, I want a pragmatic approach. I want to crawl, walk, run here, right? I want to start with some investment. Three, always know that we're all leveraging that code and capability that came before us. Now, when Daniel talks, you're going to see this in an applied sense and how it applies to you, and a very detailed sense of how to make AI go and work. I'll just cover the surface of that today. But when you look at what's required, right, it's not as turnkey sometimes as you want it to be. Now, some of the things, because I started a dozen years ago, have become turnkey that were hard for me, and we'll cover those as well. If we can go to the next bullet. So we have this saying: if they don't tell you data management is 85% of the solution, leave the meeting. You notice I put that in quotes. It's not my quote. That was the CTO of Google told that to me, 2018, right? They're the largest data company in the world, and data kicks their tails. They spend the most money on data. My best data scientist now works at Netflix, making many times the amount he made as a government employee, right? Factor of 4, right? Data management is the key behind the scene. We have the same problem you have. right? Think about that. I am pulling data from foreign websites and foreign media sites, and it's disparate and it's dirty and it's messy. And we had to build a strategy to, in the early days, to clean that data, get in a well-managed solution. And even though these were public APIs, the data was always throwing us errors. There were always bugaboos, and we had to build a strategy to overcome that, right? And in those days, I had to have a whole team and lots and lots of storage and lots and lots of cloud, because what I was doing was cleaning that data by scripting against it as it came in, right? And I had really good guys at doing that, and then binning it, and then saving every iteration of that data. At one point, it was from raw data to AI ready. It was 26 individual steps. Can you imagine, right? We don't have to do that anymore. Daniel's going to show you a much better approach, right, to get you in that high accuracy, high precision zone without that level of investment. The world has changed on us since then. But the data management is the key, right? It is getting that data to correlate, getting that data to interrelate. Then the AI can go to work. Then it can train and learn. Next slide, please. Or next bullet, please. Sorry. The other thing about that data, and I mentioned a little bit this before, it's dynamic, and I'll mention a use case here. It's going to change a lot on you, and your AI needs to adapt to that change. One of the big lessons learned we got. So around 2012, 2013, there was a shift. Publicly available information, social media began to change from Twitter and Facebook, which was very text-based, to image and video-based, right? If you have children, they don't use those. Those are old platforms. I mean, it's Snapchat, Instagram, TikTok, you name it, right? So we saw all of a sudden overnight was about 30% of our content that we trained against text was now imagery and video. So we had to adapt to that. So we brought in computer vision. And fortunately, it turns out there were open source libraries that could help us find things like tanks and battleships and airplanes and things like that. They weren't specifically tuned to things we were very interested in, but it didn't take us time long to sort of retrain those. We were able to use that data, tell the AI, hey, I want to find a T-72 that's not at home, that maybe is on the railway on its way west, because that's a very scary thing in 2014, right, for the United States, right? So find me a T-72. But we still got bias in here. And the lesson learned, I will tell you this, is because I was U.S. military, I was only interested in things in the world that were military objects, right? So we classified everything we could. Well, at one point in time, we classified bullets. And we're kicking along, thinking we're going to do about a great job at about 185 computer vision models running against billions of data records every day and getting very great returns. And then all of a sudden, the AI retrained itself and it confused bullets with fingernails. You can see how a fingernail looks like a round-nosed bullet. And we got confirmation bias. We overtrained the model, right? And that's when we realized we have a problem, right? That AI left alone does not run in perpetuity forever. You're always balancing and adjusting it. Now, to overcome that, what we did is say, hey, if you see bullet, you better see other defense and military objects in that picture, or we're going to degrade our confidence in what we're looking at. And we used other methodologies and modalities, and we also made sure that we were continuously making sure the human machine interaction was fact checking what we were saying. In the big data process like that, there's always some errors. Of the 2 million bridges in the world we found, there were 1 or 2 roller coasters. I can live with that kind of error, right? I can't live with it reclassifying and getting things flat out wrong. So watch that data. It's dynamic, and an AI approach is going to say, hey, things change, things move on us, especially where human beings are involved, right? Generally, when we look at data input from human beings in DoD writ large, we expect about a 15% data entry error, even though they're well-trained analysts, right? It's commonplace, and we guard against that. Next bullet, please. The other thing is, once we began to move down this road, and I'll sort of share a second use case here, is what we found is that AI was really good at was the things you wanted to do, right? Patterns, enigmas, change, anomalies, right? Anything that the training said was different or out of phase, it came back and said, I got something out of phase here, right? I have something that's unique or different. And that was when we'd cue the human being to come in. Now imagine, we're looking at, hundreds of millions of photographs a day. We can't hire enough government employees to look at that many photographs. The machine had to take over. What we can do is say, hey, we have questions on these, right? Another use case I'll tell you there, early in the days of COVID, and since we sort of adapted to looking at pictures and videos, we got a prediction one day of a hospital, and the tag said, I think that this is a hospital because I think I see surgeons. And the computer was only about 75% confidence in that. But when we looked at the other tags, who were tagging everything, the next tag was cleric, priest. Well, if you think about a hospital surgeon in long gowns, looks a lot like a priest in gowns, right? So the computer vision kind of knew what it was finding, but it wasn't really sure. The other thing I'll tell you about this is the power of prediction that eventually comes, right? What you begin to learn after a while, and I'll talk about this just a bit, is this. I can then say, I'm looking for change. So I'm going to train on that phenomenon, right? I'm going to train on that workflow. In my particular case, I'm going to train on a military base somewhere in the world. I don't really care about that military base in the world unless all the soldiers leave en masse, right? Or all of a sudden you see a big line of tanks lined up at the front gate, right? Now I care, right? So once we begin to get to this phase of AI, what we can do is more powerful things. What we can say is, I'm going to draw a geofence around that place, and I'm going to watch, and I'm going to look for changes, patterns, anomalies, right? It's not perfect, but what did it do? It allowed me to scale that to infinity. I can now look at every military base, right? And I only need 2 or 3 analysts for the entire area that I'm looking at just to validate what the computer found was right, rather than having thousands and thousands of analysts. That's why I come back to the first lesson learned is it saved us time, right? Second lesson learned is and Daniel will get into this too, is it really does work when we're using disparate data that has no common keys or no match of attribution or product code or things. We can overcome that with AI-based technology. And I'm going to let Daniel get into that because he gives a great briefing on that. So I think that as you emerge and as you grow in this is what you'll find, right? Now, the other lessons learned here for me is this does not replace, don't throw your business intelligence and business analyst out with the bathwater. What they're doing is a different kind of trade, right? What they're doing is looking intrinsically within a data set, not necessarily outside of it, right? And one of the things we find with AI is it's looking for the anomalies and enigmas that you're not looking for, right? It doesn't know what question to ask. So it just says, hey, this is different, which is a lot different than when you're trained to look for particular patterns and things. This is really going to start saying, as it matures, hey, I'm going to find things that help you go and enable yourself. Sure. You'll find new narratives in your data. And one thing I want to be very quick about and tell you here is this was a problem for me. The bosses would come in and they had stars on their shoulder, very intimidating. They'd say, we think there's a coup going on in this country, Terry. What's going on? And the data would lead us to a different narrative, right? It would be a good narrative. It'd be very revealing. You don't always get a direct answer to your question. You just get lots of narratives that then you have to go and define. So your initial question may vary on you, and it's important and imperative that you're patient through that. You're letting this sort of pixelated picture fill in, right? And you're going and you have to sort of manage up and communicate up here. Hey, this is initial question. It's going to move around. We're going to illuminate what we don't know a lot better, and eventually we'll get to that. But sometimes you get narratives that lead you in different directions. Be open to those narratives, right? Next slide, please. You're going to have a steep positive curve. Once you get 1 or 2 things working and they become stable and you engender trust in this, you're going to hit the hockey stick curve, right? You're going to go up very, very quickly. Great news is things will happen fast. You'll be able to do a lot more. They'll be bringing more stuff online. You can then rethink your investment. The bad news there is watch your infrastructure costs. They can really, really scale. If you use a lot of cloud and a lot of compute and a lot of storage, and you accidentally leave that on while you're running all this over the holidays when no one's paying attention, Amazon's going to send you a big bill, right? It can be computationally expensive. And so working pragmatically and thinking through, right, what the scalability, what you're doing, especially when you hit this part of the advancement. Next bullet. Getting organized is great, and Daniel's going to get into this. I can't tell you how much data management means to me to get started. If you have People like to use unstructured data as a term. If you have data that is a little unwieldy and dirty, it's okay. You can get going that. It will take you longer, right? If your data is semi-structured or you're having a hard time matching, company A's with company B's data, there are approaches that help you with this, right? And that get you that taxonomy and that ontology, and we'll get into all that you need to get going here, right? But the key here is stay focused on that level of organization here. And it's not exciting. Everyone outside of the AI room just thinks, well, we poured the data in and some magic happened and we got an output. The and some magic happened is exactly what Daniel's going to talk to you about, right? It's important, right? It's relatable. This is not PhD level rocket surgery here, right? If a state school government guy like me can do it, so I'm pretty confident so can everyone else, right? So I'm going to turn over at this point to Daniel and let him sort of deep dive your approach that will help you. And I'll stick around for any questions you may have. Thanks so much for your time today.
Thanks, Terry. And a big thanks to Pam Walters and the rest of the team at Map Connected who put this event together, as well as everyone in the audience for joining in the discussion today. I also want to say, as a new car owner who just had an issue fixed under warranty, I personally appreciate all you do to make warranty a reality. All right, so demystifying AI. Now that is a challenging task. Sadly, I'm not going to be able to peel back all the layers of the AI onion in 20 minutes, but I will make you a promise that by the end of this talk, you will leave with a warm and fuzzy feeling about AI and the future it holds for quality and warranty in the automotive industry. How does that sound? So before we answer what is AI, let's first address why should we care? Why AI and why now? It's not like AI is a new topic. People have been talking about and developing AI technology for decades. So why isn't this webinar topic, for instance, demystifying statistics, another technology that solves very important challenges in warranty? Well, for starters, statistics is more straightforward to wrap your head around, but also AI is not only important, it's hugely important, and it's really just getting started. So before we dive into the fun part, I want to introduce you to myself and Agolo, my company, so that you understand who I am and where I'm coming from. As Ted said, I'm a senior solutions engineer at Agolo, but during my career, I've also worked as a developer at Google, and for several years, I programmed humanoid robots at SoftBank Robotics, and I've also worked at Facebook, or I should say the Meta company previously known as Facebook. So as a seasoned high-tech and AI veteran, I joined Agolo because they are solving really big challenges for a number of organizations and agencies within the Department of Defense and intelligence community. But frankly, I was excited by the technology they were using to accomplish this. These government agencies have also realized that the AI approaches Agolo has been employing, and in some cases pioneering, approaches that we will be discussing today are very well suited for the large, diverse, high-velocity data sets they are dealing with, as Terry just mentioned. They have complex architectures, well-established processes and workflows, and of course, security and privacy are paramount. So all the approaches we'll be discussing today are battle-tested and well-suited to address these requirements. So this has been the nature of Agolo's work to date. But interestingly though, as our business has grown outside the public sector, we've analyzed the warranty space, learning from smart people in your industry, some of whom are on the call today. And we've come to understand that while the data is not the same, instead of hot off the press classified intelligence reports, it's hot off the press technical service bulletins. But what we've seen is actually that the data conditions, the data workflows and priorities, the high volume, diverse data sets, myriad data formats, messy unstructured text are actually quite similar. So with that introduction, I want to return to my earlier thread about the importance of AI. And to answer that, I'll consult an outside expert opinion. So just how important is AI? Well, Sundar Pichai, the CEO of Google, would put it up there with, oh, I don't know, electricity or fire. Wow. I don't know what exactly Sundar foresees in saying this, but I think it's safe to say that we're in for an exciting ride in the coming years. So all of that to say, AI is important. But why discuss it today? Well, we're here today because of a few recent breakthroughs in the AI field that have happened over the past few years and discuss what they mean for the automotive industry, and specifically to warranty and quality. So what are those breakthroughs? Well, it started with one breakthrough, the breakthrough that led to everyone's favorite virtual friend, ChatGPT. And as is often the case with breakthrough technology, this has actually had a cascading synergistic effect across the landscape of AI technologies. So in effect, it has created a bit of a perfect storm for finally being able to solve very complex, previously intractable industry challenges, such as those faced by the automotive warranty business. Challenges like complex data management, or building complex automation pipelines for things like warranty claim processing, or challenges like extracting valuable information from unstructured text, such as customer verbatims and technician reports, or the challenge of identifying patterns in massive volumes of data for early issue detection and alerting or quality improvement. So these are all challenges that can now be solved using these new and transformed AI technologies, and can be done so in reliable, cost-affordable ways. So I alluded to the fact that it's more than just one technology, but rather several AI technologies that have created this perfect storm. So what are they? So take a deep breath. I know these are all intimidating words, but to make it easier for you, I provided you with an analogy for each. So starting left to right here, ontology provides structured domain understanding, acting as the foundational wisdom. So anytime I say ontology in your mind, you can safely convert that to the AI's wisdom. Large language models are the synthetic brains processing data with human-like comprehension. They bring the power of reasoning to the equation. I might often abbreviate that to LLM, by the way. Finally, entity intelligence combines all the actual knowledge available to an organization. So this includes both industry data as well as private data, and combined, it produces a sort of private multidimensional Wikipedia. So together, this trio creates a comprehensive approach to tackle highly intricate industry challenges. So this perfect storm is really just combining wisdom and knowledge with a sort of brain. So let that digest. Now, armed with our analogies, let's tackle each of these one by one. All right, so first, let's start with ontology. So if you're doing your word replacement here, ontology again is the AI's wisdom. But first, let's look at this relationship from the other side, the wisdom side. What is wisdom? Wisdom is the embodiment of experience. So if someone has a lot of wisdom in a domain, such as Terry, it means that they have had countless rich, diverse experiences in that field and have swapped perspectives with many of its other veterans. And as a result, they've arrived at a universal understanding of that domain. So that, in essence, is what ontologies are. They're really the formalization of that type of knowledge. So indeed, ontology is a type of knowledge, but it's a more generalized type of knowledge that is centered less around facts and minutiae and more around how the components of a domain interrelate. So to summarize, an ontology is simply a shared understanding of a domain, and it is the AI's backbone. It's a sort of consensus truth that it can leverage whenever it's trying to make decisions about what to do with data. So let's take a quick look at an ontology in practice. So here we can see an ontology that shows the interplay between vehicles, VINs, models, suppliers, and OEMs. And so, of course, this is how we intuitively understand this domain, but it's important to realize that a computer does not by default have this understanding, so we need to provide it to them. This ontology, as shown, would be, of course, limited in its usefulness, given its restricted scope and detail, but full domain ontologies are actually very robust and capture all the salient features of a domain necessary to automate decision-making. So, but how exactly does having this information structured in this way enable decision-making? Well, let's start with an important fact. Computers actually don't understand the words that they're displaying on the screen. So when we store oxygen sensor in a database, all the computer actually sees is an arbitrary configuration of bits and bytes. But when we as humans see Denso 234-so-and-so mentioned on a claim, if we're familiar with this domain, we know that this is an instance of an oxygen sensor. And intuitively, we know that in turn, because it's an instance of an oxygen sensor, it's also an instance of a sensor in general. So all the generalizations that we know about sensors in general apply to it. So for instance, it is a type of electronics, and so therefore it must be connected to some onboard computer system. However, since computers don't actually understand our data, unless we explicitly provide these relationships to them, they simply can't make that leap. So, but by doing so, they can actually almost magically draw the same types of conclusions about our data as we can. So if you pause and think about that for a moment, the computer is now suddenly able to generalize and reason about our data. So how does this actually apply to the automotive warranty space? Well, one of the challenges we've heard consistently in this space is that the amount of manual investigation required to get to the bottom of a claims issue or a trend issue, all the searching for and reading through different data sources, just trying to extract the pertinent information we're looking for. There's also the challenge of trying to automate warranty claims workflows, given the complexity of claims and also the amount of data, different data sources required to cross-reference. So building out domain ontologies for each of these pertinent data sources can unlock this type of automation. And whereas previously the creation and maintenance of domain ontologies was a prohibitively tedious and time-consuming task, with the assistance of large language models, aka the AI brains, which we'll talk about next, building and maintaining these domain ontologies has become much, much easier. So testifying to the power and utility of ontologies, despite the significant effort it has historically taken to develop them, 75% of Fortune 500 companies report that they are leveraging either ontologies or some other form of data semantics program. Furthermore, it is estimated that there exist somewhere in the order of tens of thousands of domain ontologies out there in the wild. Okay, time to put a fork in ontologies and move on to large language models, or if you remember, the brains of the operation. So of course, ChatGPT is the famous one of the group, but there's actually no shortage of large language models on the market. And a number of them actually can already be deployed in private, secure environments. So you don't have to worry about your data spilling into the data provenance of OpenAI. Okay, so, but what are LLMs? Well, our analogy is actually very accurate. The architecture of these LLMs and sort of these neural networks in general is actually modeled directly after our brains, and specifically the synapses and neurons. So how exactly does our brain work, and by extension these large language models? Well, they operate by pattern recognition. So imagine a toddler seeing a cat. Initially, the child's brain is struggling to categorize it. It's processing its features through various neural pathways. But as the child hears the word cat repeatedly associated with the creature, the recognition sort of solidifies it. So similarly, if the toddler mistakes a dog for a cat and it's corrected by adults, similarly, its understanding is refined. So neural networks function in a very similar manner. Each neural pathway focuses on recognizing a specific part of an overall pattern, maybe a tail or a sound. And then at the end, it's all added together to determine if what we're seeing is a cat, a dog, or in this case, a zebra. And so that, in essence, very simplified, is how these models work. So, but why are they relevant? Why is this relevant to us? By now, you're probably thinking, I don't need to identify fuzzy creatures in warranty, or I don't need a glorified chatbot like ChatGPT. So how can they help? Well, the thing is, LLMs are actually incredibly versatile. So out of the box, they can handle all sorts of arbitrary language and reasoning tasks, but their capabilities really start to shine when you start to pair them with other technologies. For instance, by giving them read access to a database or other data sources. So here are just a few examples that we at Agolo are applying LLM technology to with compelling results in the warranty space. So everything from ontology creation to verbatim text processing to metadata enrichment to more sophisticated reasoning tasks, even natural language querying interfaces. So you can literally just ask the system in plain language for the type of report you're looking for, and then it does all the heavy lifting for you and just asks you back if you want that visualized as a chart, a table, or however. But of course, this list isn't by no means exhaustive of all the possibilities. And I might also add here that LLMs are a developing technology. And if anyone remembers Google's Bard announcement from earlier this year, their sort of ChatGPT equivalent, it gave false information in a very public demo. Interestingly, in the LLM world, they call this hallucinating information. And it sounds bad, but there are actually already numerous effective techniques available today to mitigate against this possibility. And the goal is actually right on the cutting edge, pioneering new state-of-the-art verification techniques. And it's actually in talks already with organizations within the DoD about a grant opportunity to develop some. So that brings us to entity intelligence, the third of our three analogies here. And it is, if you remember, the knowledge in the medley. So what is entity intelligence? So first off, let me explain what I mean by entities. It's the more foreign word in the phrase after all. So it's really just a fancy word for the individuals, the places, the things, the concepts, or really any distinct item that exists in your data. So in the case of warranty, that can be parts, products, causes, assemblies, and so on. So what is entity intelligence then? It's really just the extraction and consolidation of entities referenced in data and their salient information, and marrying that together and storing that in what we call a domain intelligence graph. And I should add here that data extraction entity information, it also includes the relationships between the entities. So it's this connective tissue that you'll see in just a few slides that unlocks very powerful analytics capabilities. So let's apply this to the warranty space. So we all know how useful a claims verbatims can be in deciphering troublesome claims. And we know that verbatims in general actually hold very rich information. If only there were a way to extract that information reliably and append it to the claim, right? So enter entity intelligence. Entity intelligence actually draws on both ontologies and large language models, as well as a variety of other AI and data science tools to tackle challenges exactly like this. And before we zoom in here to verbatims, I want to point out that this is a general technology and capability. So while we're about to apply it to verbatims in this case, keep in mind that this same technique can be applied to technical service bulletins, to repair procedures, NHTSA reports, contracts, you name it. Virtually anywhere in your system that deals with unstructured text. So with that in mind, let's zoom in on a warranty claim and specifically to the technician's report as captured in the correction verbatim. So what you see here on the left is actually an actual technician verbatim, and it's pretty characteristic of what you see. Some may have more information, some may have less. Around 60% or so that we've seen have at least one diagnostic trouble code or DTC, and many have several. These are often fraught with misspellings, abbreviations, acronyms, and all sorts, and all come with this sort of characteristic shorthanded abridged sentence structure. So before we move into entity extraction, we first want to make sure this text is cleaned up so that we're extracting good information. This is where LLMs can come into the picture. So first, the text gets cleaned and converted into proper grammatical format, and then the engine is able to parse out these key entities. You can see that in the step 2 here. Next, moving to step 3, while the entities in the text have been identified, the information is still not that useful, right? I mean, so what if we've identified that P1198 is a diagnostic trouble code if we don't actually know what that trouble code is? So this is where we actually link the identified entities to the real world records. This is a process called entity linking. And after that entity is linked, we can then run all sorts of text analytics, extracting that salient information, and then storing it in that domain graph I was talking about earlier. So all of that combined, the end result might look something like this, right? So we've taken this unusable sort of typed chicken scratch on the left and converted it into cleaned, organized, connected information on the right. Ontologically, we know that correction verbatims typically include these 4 categories of information: symptoms, diagnostics, faults, and repairs. Then within each of those, we provide a structured entity-centric view of that extracted linked information. The data is cleaned and organized so that suddenly all of this information is now available for downstream analytics. So for example, here we can see SES light on the left in the original claim actually means the service engine light, and that is part so-and-so. And if we go further, the status of that is on. We can see that the reference DTCs are all related to exhaust gas temperature sensor number 5. We can see that the faulty part was identified and it corresponds to the DCCs. We can also see that the repair actions coincide with the problem. And I stopped here, but we could even go one step further. For example, we could pull in the DTC recommended repair steps and compare it against the actual repair steps taken. So hopefully you can see, but this approach is really the gateway to highly advanced claims processing automation. So let's zoom out a little bit and look at what is actually happening here at a high level. Entity intelligence is taking in third-party data, along with both your unstructured and structured data, processing the data using ontologies, text analytics. It's linking it, enriching it, all to create this sort of internal, multi-dimensional Wikipedia, or what we call a domain intelligence graph. That's enabling powerful downstream applications from automation to intelligence to alerting and more. So part of what makes this architecture so effective is that once data is ingested and those entities and relationships identified, the insights and analytics become exponentially more powerful because the system understands second and third order relationships. So here's an illustrative example. So let's say we have ingested and processed parts and product data, DTCs, TSBs, facility information, and with all of that data, we've built a graph that really understands how everything is connected. So it understands how each entity instance, for example, a vehicle part that has been replaced, is related with not only the instant VIN, make, model, and dealer, but also against the related claims and the specific technician who did the work and his or her association with related claims and claims with the same or similar parts. It's also a real-time or can be near real-time system, so it can continually assess the relationship between the instant part and the assembly plant and production run, as well as the associated supplier and the terms of that supply agreement. So with this continuous evaluation of all these relationships, the system can identify outliers, detect emerging trends, and alert the user on potential fraud activity or production challenges. This is a simplified example, but hopefully it communicates the power of this domain intelligence graph. It makes possible real predictive analytics, tracing, alerting, and also makes claim investigation more efficient. So how can this be applied to us? So the underlying technology we've discussed today makes possible many capabilities that are required to maintain competitive advantage in your industry. Everything from claim processing, automation, and classification to proactive trend and fraud detection, quality monitoring, as well as unified read-across analytics and on-demand reporting. Though, as Terry said, there is no easy button for real-world AI, but if deployed properly, the underlying technology we've discussed today can achieve many of the goals we've learned are important to this space. So that was a lot, but we made it through. We've come a long way in 20 minutes. In that time, we've discussed ontology, large language models, entity intelligence, and these are acting as the wisdom, the brain, and knowledge. Together, these three pillars form a powerful framework to address complex challenges, providing both breadth and depth in analytical capability. So that wasn't so bad, was it? But where does that leave us? So I wanted to finish with this slide, which I think captures a lot of the thinking about AI as this scary blind leap we all have to take when it comes to either adopting or not adopting. But I think we all know that's not realistic. No one wants to, nor is it even possible to entirely rip out a fully functioning existing system to adopt some new technology that is going to come with its own challenges, its own learning curve, and its own issues. So based on our experience at Agolo, we believe AI integration should follow an iterative, evolving adoption process. So it's not scary, and your organization has time to adapt and assimilate it and learn how to work with it. With that, I'll pass it to Jason, but hopefully by now you understand the AI domain a smidge better and feel that warm, fuzzy glow I alluded to earlier, knowing that the automotive warranty space is about to see some fresh innovation.
Thanks, Daniel. You somehow managed to take a complex and to be honest, somewhat intimidating technology and make it a bit easier for us to digest and understand. So we appreciate that. Now that we've heard how this technology is being used currently for analyzing massive data sets in other sectors, where security and accuracy is critical, as well as how well suited the core technology is for handling things like warranty data and automotive, next question is, how do I get started? Well, the first step, if you've not already taken one, is to determine your organization's current gaps, your wants, your needs, maybe some areas of deficiencies that you might have. I'm sure many of you on the call today are familiar with the AIAG CQI 14 Automotive Warranty Management Standard. This automotive standard includes a great self-assessment tool for OEMs and suppliers to use to help identify not only strengths, but then also gaps in your own warranty management processes. And it's usually a good place to start whenever you're looking into a project or initiative such as implementing AI. From there, you can determine if you can or even want to build what you need in-house, or if you want to partner with an external company. You can then identify the appropriate balance between integration into your existing systems and applications versus a rip and replace approach. You can then evaluate partners for scalability, explainability, data security, and ease of integration. And then finally, scope and phase a proof of concept or a proof of value in a manner to help realize fast, measurable impact, and then potentially expand that throughout your organization in a wider form. So now, thinking back to our speakers today, Terry and Daniel, they did a really good job taking a topic that could realistically have been a full day workshop by itself and condensing it into 40 minutes. However, if you want to learn more, the team from Agolo is offering a complimentary AI assessment and analysis to OEMs and suppliers. They provided the QR code that you see on the screen to quickly contact their team if you have a desire to learn more. This complimentary assessment involves evaluating your current claims process and data flows, as well as your security and data stewardship protocols, analyzing relevant sample data to understand how and where AI could help your organization. The Agolo team would then present their findings to you, as well as a proposed solution approach that makes sense for your organization. This help includes identifying bottlenecks and solutions, and outlining potential next steps. And again, this is complimentary, and you can either scan the QR code with your phone or use the email address at the bottom of the slide to contact the team directly. So with that, I'm going to turn the meeting back over to Ted for a wrap up and then hopefully some Q&A.
Thank you very much, Jason. So as you know, the conversation will continue at the Vehicle Service and Warranty Lifecycle Summit in October. And what's fun there is also for all webinar participants, it's a buy one, get one free offer. This is offered through Map Connect and is valid through, meaning you can sign up, valid through Friday, September 29th. Use the code AGOLO 2023. So we'd love to see you there. A lot of value added meetings going on there, but it'll be very interesting and we'll continue with this conversation.